Right, this is video 3 for Module 12, where we've been talking about the electromagnetic force, which has to do with electricity and electric charges. So inside an electrical circuit, which is what we use every time we plug in a device, these electrical circuits use the difference in potential energy between the battery or the voltage in order to create an electrical current that flows through, which allows us to use the device. So the battery is where the electrical charge is stored. Batteries are going to have a positive side and a negative side. The negative side contains electrons. The positive side doesn't contain electrons, and therefore you have a potential difference. You have a negative side and a positive side. What you're wanting to happen when you complete a circuit is you connect that positive to the negative so that the electron can create a circuit or create a current where the electrical field flows. So now the book talks about how when you connect the two, your electrons actually move from negative to positive. The electrons don't ever actually really move. They move a slight little bit in a DC current circuit where you have a battery circuit. And the stuff that you're plugging into the walls to turning on your lamps or to charge your computer or to make your TV work, the electrons don't move at all. What's actually moving is your electric field. But when we talk about the current flowing, not necessarily electrons, but the current flowing is always going to be flowing from the negative side of your battery to the positive side of your battery. So you're wanting to go from negative to positive. You can remember that if you just equate that with our Christian walk. We are wanting to move from the negative in our lives towards the positive. Moving from a life without Christ to moving to a life with Christ. Moving from sin into righteousness. Moving from the negative to the positive. So when a current is flowing, it's flowing from the negative to the positive. Now, when people in the past, and I don't know why they always did it wrong, but in the past, when people draw a conventional current, they're going to draw it and say that they're moving from the positive to the negative. It is incorrect, but that's what's called the conventional current. It's because a long time ago, before they figured out that it was moving from the negative to the positive, they would always draw the circuits moving from the positive to the negative. Once they learned that it was incorrect, they didn't change it back. Sort of how once we discovered that the metric system actually is easier to use and better, we've never moved to the English system just because it's hard to get people to change their minds once they know a certain way. So there's the correct way and then there's the conventional way, and so you need to know both of them. The correct way is from negative to positive and the conventional is from positive to negative. So voltage, which is contained in the battery, that is how hard the battery pushes the current through the circuit. So the higher the voltage, the more the current is going to be pushed. It's the strength of the pushing. So if we imagine each of us as being part of that current, we are the current flowing down the hallway from leaving our science room. Voltage would be someone standing at the door pushing you out the door if you were current to flow down the hallway. Say that our room is the battery and the hallway is the circuit, and voltage would be Damien or somebody standing at the door pushing us out the door. That would be voltage, is how hard the battery pushes. So Damien could either push us with a little push or he could push us with a hard push. That is going to be voltage. Current, which is where the electricity is flowing, that is going to be measured in amps or amperes. That is measured with a capital A. When we signify that, we're calling that a capital A. Voltage would be a capital V. Now, if you have a low voltage and a low current, it's relatively safe. So completing the circuit on, say, a AA battery, relatively safe. A AA battery has very low voltage. There's going to be low current flowing through. And if you're connecting it, if you've ever picked one up and held it on the positive and negative ends, you have completed that circuit. You have completed the circuit between the positive and the negative sides of your battery. But your body offers a lot of resistance, so there's a very low current flowing through there, so it's pretty safe. Anytime either voltage or current is going to be high, then that's when it's dangerous. So if you have low voltage, low current, that's safe. If you have low voltage, high current, that can be very dangerous. Or if you have high voltage and low current, that is also very dangerous. If you ever are out at any of, like, near the electrical towers, the power towers that are out taking power in and out of businesses and homes, some of those power stations, they say high voltage, danger, is because anytime you have either one of those, high voltage or current is high, it's going to be a very dangerous situation. So if this was a drawing of an electrical circuit, this is the simple drawing. This is without any resistance in it. You have your battery, which is designated by your long and skinny lines here. The long line is always going to be the positive, and the short line is always going to be the negative. And that's really important because remember I told you you need to know the way the current flows and the way they say in the conventional how it flows. For real, it flows from negative to positive. We are moving from the negativity of our life towards the positivity of Jesus Christ. That's for how it really moves. But then the conventional drawings are going to draw it from positive to negative to positive. So you got to know both. So whenever we do it, we have our battery in the center. Our positive is the long one, and the negative is the short one. So you can remember that if we're remembering that we're going from negative to positive in our lives. We want there to be less sin and more righteousness in our lives. So our positive is going to be our righteousness. Our negative is going to be our sin. So this would be an example of a current drawn from your negative to your positive, which is the way it actually flows. So whenever I have you draw a circuit and draw a current, I'm probably going to tell you to draw one of them solid line and one of them dotted line, just because you're not going to change pen colors. But make sure you have arrows the whole way through so that I can see which way it is flowing. Okay, so that would be the actual current. The conventional current, though it would be drawn from the positive to the negative. So that's how I've designated with the red lines on the inside, going from the positive side to the negative side. So click on the link and complete the quiz, and I will see you in class.